Okay, this is MAT 175, lesson 28, section 6.4, graphs of sine and cosine. Okay, to start with, it helps to illustrate the relationship between our sine or cosine curves and the unit circle. So here's our unit circle, and here's our values from 0, pi over 2, pi, 3 pi over 2, and 2 pi. Where at 0, cosine is 1, sine is 0. And we're not going to look at tangent at this time. We're just looking at sine and cosine. So pi over 2, cosine is 0, sine is 1. At pi, cosine is negative 1, sine is 0. At 3 pi over 2, cosine is 0, sine is negative 1. And back to 2 pi, cosine is 1, sine is 0. So here, we're going to see that our sine curve starts off at 0. At 0, here's sine, 0, and our angle is 0. And then up at pi over 2, our sine curve comes up here to 1. And so then as we continue on down to pi, our sine comes back down to 0. And then at 3 pi over 2, now sine is at negative 1. And then at 2 pi, sine is back to 0 again. So if this sine curve continues on indefinitely, around and around and around, you get this sine curve that continues on. Here would be, 2 times around would be 4 pi, 3 times around would be 6 pi, and so on. And it also goes on in the negative direction. And this would be negative 2 pi. So if we were to go clockwise, then we would get, if we were to go clockwise, then sine would be negative 1. That's where that is. And then back up to negative pi, and then it would be at sine is 0, and so on. Now for cosine, we can see that when our angle is 0, cosine is 1. So cosine starts off, when our angle is 0, cosine starts off at 1. And so then we continue on around to pi over 2. Now cosine is at 0. Well, here's pi over 2. Cosine is at 0. And then we continue on to pi, and cosine is at negative 1. And continue on to 3 pi over 2. Cosine is now back to 0 again. And then 0, at 2 pi, then cosine is back to 1. And as we continue on around and around, cosine, there'll be 4 pi and 6 pi and so on. And these graphs could go on indefinitely. So we go on in negative direction, clockwise direction, but we have a negative pi over 2, cosine is going to be 0, and then negative 1, 0, and negative 1, and so on. Okay, so let's take a look at some basic properties of sine and cosine. Here we have y is a times sine times omega x, where a is the absolute value of a is our amplitude, and omega causes our graph to horizontally compress or stretch. If omega is greater than 1, it's going to cause it to horizontally compress. And the reason for that is because our equation for our period is 2 pi over omega. So let's say omega was 2. Then, so instead of being 2 pi, this would be 2 over 2. Our period now be 1 pi. So our period went from 2 pi to 1 pi. And when omega is a fraction, basically, between 0 and 1, then it's going to cause it to horizontally stretch. So one cycle, instead of going to 2 pi, may go to, let's say, 3 or 4 pi or more. Our increments we're looking at, since, and this is going to be true for sine or cosine. So our increments, now here, when omega is something other than 1, then instead of being here pi over 2, pi, 3 pi over 2, and 2 pi for our incremental points, we have to multiply omega times each of the denominators. And And so that will help us to determine what our new increments are. So here we have y equals to cosine, y equals to 3 times cosine x, where amplitude is 3, omega is going to be 1, and so since omega is 1, this will be 2 pi over 1, or just 2 pi. And so our curve will go from 0 to 2 pi, and so our increments are going to be the same at pi over 2, pi, and 3 pi over 2. And our amplitude, our baseline is at 0, so that's going to go up to 3 and down to negative 3. Okay, now let's say that we have here a graph of y equals to 2 sine and then 5x. Well, let's take a look at our parent graph first. For y equals to sine x, starts off at 0, comes down and then back around to 2 pi, and here's our increments of pi over 2, pi, and 3 pi over 2. And our amplitudes go up, baseline is 0, goes up to 1 and negative 1. For this graph, the amplitude is not 1, it's 2. So now it'll go from 0 to positive 2 and then down to negative 2. And since omega is 5, our period is going to be 2 pi over omega, which is going to be 2 pi over 5. So that means our period is not going to go from 0 to 2 pi, it's going to go from 0 to 2 pi over 5. And so that's going to change our increments here. And let's see how we figured that out. So here's our amplitude, our baseline is 0, so it goes up 2 and then down 2. So the way we figure out our increments is we start with 0 pi over 2 times omega. Since omega is 5, then this will be pi over 2 times 5 is pi over 10. So instead of pi over 2, now we're pi over 10. And then here, instead of pi, here we look at pi over omega, which would be pi over 5. And then now the next one, instead of being at 3 pi over 2, this would be 3 pi over 2 times omega, and the denominator, so this would be 3 pi over 2 times 5 is 10, so that would be 3 pi over 10. So this would be 3 pi over 10. And then, of course, we already figured out that the last one would be at 2 pi over 5. So instead of our sine curve ending up at 2 pi, it horizontally stretched, or compressed rather, to 2 pi over 5. Alright. And so we don't normally have to look at it, like that. We can just draw a regular sine curve like we normally do and just change the increments. We don't have to change the graph to do that. Okay, so next we want to look at y equals to plus or minus a sine omega times x plus or minus c, or plus or minus a cosine plus or minus omega x plus or minus c. Whereas the plus or minus in front of the sine or cosine are going to cause the graph to reflect about the x-axis. Like as if we had y equals to x squared, opens up as a parabola, and the negative is in front, the parabola opens down. The plus or minus inside here reflects the graph about the y-axis. For example, like when we had our parent graph of the square root of x, open up and to the right, when we have a negative inside, that's going to make it reflect about the y-axis, and so now it's going to move up and to the left. Alright, now this plus or minus c here, that's going to make it shift up or down by c units. Like if we had x squared plus 2, that will make our vertex shift up to 0, 2. And so we get that shifting up effect, just like we would for any other parent graph. Alright, so here's our parent graph for y equals 2 sine x. And let's say we want to look at y equals to negative sine x. Well, instead of coming up to pi over 2 and 1, we're going to go, because it reflects, now we're going to go down to negative 1 at pi over 2. And then come up and then around. And so this would be pi and 3 pi over 2 and 2 pi and so on. Okay, so let's look at another example. Here we have y equals to sine negative x. So basically that's going to cause the graph to reflect about the x-axis. So we're going to start off here at 0. Instead of going up to the right, we're going to go up and to the left. So it's going to make it do that, and then come back down, and then to negative 2 pi. Well, when that happens, it's going to go back down the other way as well, because the curve has to maintain continuity. And so it looks like the y equals to negative sine x, like it reflected about the x-axis, but that actually reflected about the y-axis. And so that's why we said before with the even-odd identities, when sine of negative x equals to negative sine x. So we've shown graphically how that even-odd identity works. Okay, next, y equals to cosine x. Here's our parent graph, and so that starts off at 1 and comes up and around to 2 pi. So when we have y equals to negative cosine x, instead of starting off at positive 1, now it's going to start off at negative 1, and then come up and then around like that to 2 pi like that. And so this is still here at pi over 2, and this is 1 pi, and 3 pi over 2, and then 2 pi. And so, the graph, if you wanted to go in the negative direction, would continue on that way. So that is reflecting about the x-axis with the negative in front of the cosine. And now, when we have y equals to cosine of a negative x, we're going to start off here at 1, but instead of going to the right, it's reflected about the y-axis, so it's going to go to the left in the negative direction, and then down and around, and it'll end up at a negative 2 pi. But when it does that, then you have to go the other way as well. And you can see that this looks just like the parent graph. So with the even-odd identities, we can see that cosine of a negative x is the same, is equivalent to cosine x. So we can see graphically why, when we had for the even-odd identities, when cosine is a negative x, that equals to a positive cosine x. Okay, now here we have sine x plus 3. So we start with our parent graph of y equals to sine x, and so here our baseline is 0, and it comes up and around to 2 pi, and so this is from 1 to negative 1. Here's pi over 2 pi, 3 pi over 2, and 2 pi. So now our graph is going to shift up 3 spaces. So if we started off here at 0 like this, and we shifted up 1, 2, 3. So now our baseline is at 3. And so our amplitude, we see there's nothing in front, so that has to be an amplitude of 1. And so that means that our baseline is 3, so it's going to our amplitude is 1, so it's going to go up 1, so we add 1 to 3, so that gives us a 4, and a minus 1, and it goes down to 2. So it's going to oscillate. Our baseline is at 3, but it's going to oscillate between 4 and 2. Well, instead of drawing it like this, it's easier just to show where it starts off at 3 and draw the graph the same way, and then look at 3 and then up 4 and down 2 like that. So that's acceptable to graph in this case, our sine curve like that. Okay, here we have 2 cosine x minus 2. Alright, so our amplitude this time is 2. And so omega is 1, just like omega here was 1. So the period didn't change any, so our period is still 2 pi. And this time it's going to shift down 2. So it helps to start with our parent graph, especially for cosine, because sometimes people get a little confused with cosine. And so here's our baseline at 0, and so it starts off at 1, comes down and around to 2 pi, and here's 2 pi, 1 pi, 3 pi over 2, and 2 pi. So our graph is going to shift down 2 spaces. So now what we do is we use it, since it shifts down 2 spaces, our baseline is now at -2. And so since our baseline starts at -2 and our amplitude is 2, we're going to take -2 and we're going to add 2, and so that makes the graph go up to 0. And we're also going to subtract 2, and that's going to make it come down to -4. And since omega is 1, we're still going to go to 2 pi, pi, 3 pi over 2, and 2 pi. So our period has not changed. Okay, here we have y equals to -2 cosine pi times x. And so the negative, that's going to make it our graph reflect about the x-axis. And so we're always looking at the amplitude as an absolute value. So our amplitude is just 2, not -2, just 2. The negative just tells us that it will reflect about the x-axis. So it helps to see that we will go ahead and start off with our parent graph at 1. So it also helps to go ahead and reflect the graph first. So instead of starting off at +1, it's going to start off at negative and come up and around. But because our amplitude is 2, it's not going to be 1 to -1, it's going to be up to 2 to -2. And our omega is pi. So that makes our period of 2 pi over omega 2 pi over 2, and now that's just going to be 2. So our increments are going to be 0, 2 pi over omega, pi over 2 times omega. So since omega is pi, this will be pi over 2 times pi, and that will be 1/2. So that will make this, instead of pi over 2, it will make it at 1/2. And then for pi, that will be pi over pi, pi over omega, we'll make it pi over pi, and that's 1. So instead of here being at pi, now it's at 1. And now the next one, instead of being at 3 pi over 2, 3 over 2 times omega, we'll make it 3 pi over 2 pi. And so the pi's cancel and we get 3 over 2. And then the last one, we already knew that one was 2, because that's what we got here. Alright. Now for the next one, y equals to sine of -1/2 x plus 3. Again, we start with our parent graph, and we have 1 and -1, pi over 2 pi, 3 pi over 2, and 2 pi for our increments. Our amplitude is 1. This negative here, that makes it cause the graph to reflect about the y-axis. So instead of the graph starting up and to the right, it's going to start up and to the left, come down and around, and then it's going to come around the other way, so that makes it look like it reflected about the x-axis. So we want to do that first. And we see that it's shifted up 3, so our baseline is going to be 3. And since our amplitude is only 1, then it's going to be up 1 to 4 and down 1 to 2. And so our period, since our omega is 1/2, then our period is going to be 2 pi over 1/2, which we're going to take our reciprocal, our denominator, and apply the reciprocal and multiply. And we get our period is now 4 pi. And so you can see that these are going to be increments of 4. And so we, We can go ahead and apply our increments like we would before, and we get pi, 2 pi, 3 pi, and 4 pi. And that is the end of this lesson.